let's do this. Okay. Count of substrings containing every vowel and k consonants. Level 2. You're given a string word and non-negative integer k. Okay, so let's go ahead and create a length of the string variable, or the string is called word. Return the total number of substrings of word that contain every vowel at least once and exactly k consonants. So there has to be at least one vowel and exactly k consonants. Okay. So here k is one consonant and return the total number of substrings. Okay, so like subarrays are substrings. Any contiguous portion of the string. Here there's no substring with, oh, okay, sorry, every vowel at least once. I thought it was just having at least just one vowel. Here A, I, O, there's no U at all, so you can't create any substrings there. Here there is one substring that has all the vowels and 0 consonants, and that's the whole thing. Here, so I appears a couple times, E appears a couple times, A appears a couple times, O and U appears a couple times, and you want 3 Qs. So for instance, so there's 2 Qs there, so there's a third Q there, so that's 1. And then why would this not be? Why wouldn't this also work? So like if you ignore the first letter, the substrings with every vowel and one consonant are, oh, it's one consonant, my bad. I thought it was still 3 consonants. Okay, so that's 1. And then Q, that's 2. I don't know, starting with this Q, ending before the other Q, that's 2. And then starting there, ending there, that's 3. Okay. So what you would probably do is, again, this seems like a sliding window one, which has been the last couple of coding problems. So what I would do here is I'd probably do a sliding window technique. I'll open the window to extend window right index to the next to the last consonant. So there needs to be k consonants within the window. So I extend all the way until I hit k consonants. And then check if all vowels are within window. Increment 1. So if all vowels are within window, increment answer by 1. And do this, then remove left index of window. This is kind of like window closing. And let's see, you'll do this on repeat. So repeat, move left side of the window. If removed letter on left is vowel, check again. if and increment answer if vowels are still there. If condition is okay, and then if removed letter is consonant, how do you spell consonant? Consonant. Window is closed. Stop repetition. Okay, so let's do a small case example. So let's say you had a simple one. So let's say let's say a consonant. Let's use K. Now let's use P. P-A-I-O-U. P. I'll just capitalize the consonants to make this easier to see. P-P-A-E-I-O-U. P-P-A-E-I-O-U-U. Okay, and let's say for sake of clarity here, K is equal to 2. So what will happen here is this sliding window technique means you extend out the right side of the window until you actually reach your second consonant. So it'll be that one. And at that point you check, you kind of keep track of how many vowels are within the window as well. And you say, well, are all of my vowels in this window? And if it is, then however long this window is, this is going to be an answer. Or whatever substring that this window encapsulates, this is going to be an answer. One of the answers. So you increment the answer by 1. And then you close down the right side of the window, or left side of the window. So you have the left side of the window be that. And you check, did the left side letter that you kind of closed on, was that consonant? If it was a consonant, then now your sliding window kind of a key condition is invalidated. So it's no longer the case that there's k consonants. There's going to be k-1 consonants at that point. So you stop that. And now your window is this, and then you extend out the window on the right. This is a constant that you added, so this is now it's good. So you increment answer by 1. After that, you're going to repeat moving the left side window. So you move to remove like the A on the left side, and so since it's a vowel, you check again if there's still at least one vowel within at least one of each vowel within this substring. It's not because there's a missing A. But that just means that you don't increment the answer. You still will continue to repeat on the left side until you hit until you actually remove a P or a consonant. So like the right side of the window stays there, and you keep on doing it on the left side, removing from the window until finally you reach removing the second P. So now this is your window, and then you increase your window until there is a consonant on the right side. So now your window's there. That's good. Increment 1. All right. So on and so forth. So let's go ahead and just say answer equals, there's 0 counts right now. Consonant count is going to be starting with 0. We'll say left index equals right index. We'll just do left and right here. Left equals right 0. And then we need to keep track of the vowels. And the best way to keep track of the vowels is I can't use a set because a set would just be keeping track of whether or not the vowel exists. I'll use both a set um, and a counter. So vowel set is equal to a set of vowels. Vowel count will be, I guess I'll use a default dictionary. Default dictionaries are basically ways to map vowels, in this case mapping vowels to the counter of how many vowels there are. So this will have a default value of 0 for each thing that you map into it. So A will start with 0, B will start with 0. So for each index, actually, I'm going to use a while loop here. While the right side index is less than n, I'm going to say the letter at that spot is going to be word at the right side. And then if this letter is a vowel, so it's in the set of vowels, I'll say all vowels is a set that is A, E, I, O, and U. So it's in all vowels. Let's do the consonant case actually, because that's the one that's easier. Is not in all values, then this is a consonant. So consonant count plus equals 1. If the consonant count is equal to k, then we're going to check if there's all vowels. If the length of if the length of the vowel set that we have is equal to 5, then we're going to increment the answer by 1. Okay, actually this is going to be more complicated. Then basically need to close left side of window until less than k consonants. Okay, so I'll do that a little bit later. Else, this is the case where it's actually a vowel. So if it's a vowel, then we're not going to increment the consonant count. We're going to have vowel set dot add this letter. So because it's a set, it doesn't treat duplicates. If it's a duplicated letter that's already in the set, it just doesn't do anything. But if it's a new letter in this new vowel, like let's say there's the vowel set only has A, and there's an I, and then it adds it to it. That set is added, and then the vowel count for this letter is incremented by 1. Okay, so I think that is fine. Okay, so the only logic here is the kind of important closing logic of the closing the left side of the window. So we'll say left index is equal to, so actually while, so the condition here is while the consonant count is equal to k, we're going to say the left letter is equal to the word at the left index, and if the left letter is if letter is not in, oh, what am I doing here? Is not thing. If the left letter is in, let's do the easy one, is not in all vowels. then this is a consonant, so the consonant count decrements by 1. Eventually we'll need to decrement the left letter. Else, so this is a vowel. I'm going to decrement the vowel count of this letter. So vowel count for this left letter decrements by 1. And if it reaches 0, then I need to remove it from the set of the vowel set. So if vowel count for this left letter is 0, then vowel set of this left letter dot, I think it's just remove this left letter. Okay. So if you remove a consonant, then you know that this can't be a still correct window, like the window, the condition of the okay consonants is false. But here, even after we remove the vowel, it's possible that this now kind of smaller window is fine. So just doing a check here if vowel set, if the length of the vowel set is equal to 5, there's all vowels, then therefore the answer should append by 1. Increase by 1. Okay. And I think that's correct. So I'm going to return the answer here. Okay, so literal string unterminated. Whoopsie. Default dictionary 0. First argument must be callable or none. Oh, default dic. Is that how you do it? That was default dictionary is not defined. Did I misspell this? Default dictionary. What did I do wrong with this default dictionary? Oh, it's default dictionary of integer. Oh, okay. It's you need to actually say the type. Default dictionary integer. I think that defaults to 0. Oh, I keep on screwing up. This is a while loop, and normally I do, or often I use for loops for Windows, and it automatically increments the indices. But since it is a while loop, it does not automatically increment the indices. So you need increment here, right? Plus equals 1. Set object is not callable. Vowel set. No, oops, vowel set. Remove left letter. Oops, this is left. This should be incrementing the left side index. Interesting, interesting. My answer was 0. Oh, okay. I know. So if it is if there's 0 for the number consonants. How would that work exactly? Okay, so this is a case where if it ends up being that the right index is actually at the very end. No, that should have worked here. So when the right index is at n-1, then you have z, your consonant count should be equal to 0, and your vowel set should add the letter. Okay, so there should be a condition here where even if you don't add, this is just a very special case. So you add the letter, I think you need to still check, huh? Add the letter. Oh, this is really special. Okay, so even if you have the letter, this is not special 0 consonant. There's only this special case when k equals 0 that somehow you add a vowel to your window and it still is that your window is matching the condition. So if k equals 0, then if length of vowel set is equal to 5, then answer plus equals 1. Now, let's say k equals 0. Do you need to actually close down the right side? You kind of do. So for instance, if you had a test case that was, let's say, repeated, okay. Let's say A, E, I, O, U, U, E, I, O, U. So how many substrings work here? So that one is the first one that works. Now, do you want you to extend further to the right? So this one works, this one, I mean, every substring works. So if you extend out to the right, you go as far right as possible. But then that does mean that when you go closing to the left side, you're possibly missing some windows. Like, for instance, the window that might be E. So you're counting this window, you're counting this window, you're counting this window, you're counting this window, counting all these windows. But then that means that all your windows start at 0 index and end at some incrementing R index, right index. But it could mean that you're skipping over maybe this to this. Second, starting with index 1 and ending with index like n-1. So you don't want to extend out the right side window before you close out the left side window. Then if you close down the left side window, you might be missing out on things that start out with like index 0. Oh man. I wonder if this is an issue with other portions of code. You open the window as far as possible on the right. Open the window as far as possible on the right. You know what? What was the other one that I just did here? Okay. I wonder if this one just works or not. Let's do a test case. Is this something wrong with all possible words, or is it just words with all vowels and or words, yeah, with zeros consonant? Do a small test here. Alright, P is no good. Yeah, so this thing doesn't quite work because of the way that I'm handling the vowels here. So it's going to see PP here. It's going to close down the left side. Then it's going to do PP. If it's a vowel that adds, then this should. Oh, if it's the vowel that's add here, then this definitely should just check to see if the condition is true, and the vowel added doesn't really change anything. Okay, so this thing should just be a special condition. If consonant count equals k, the answer should be incremented by 1. So my answer went to 3 here. Now my output's 3. Interesting. Let's go ahead and just print the substring here. Word from left index through right index plus 1. Again. Oh shoot, this is the consonant count is k and the length of the vowel set equals 5. Actually not sure how this answer is still so low. Here again I'll print. Actually, print down this answer, and I'll print the answer here. So this should show all the things that's counting as an answer. Word to right. So are these correct? Yeah, so that P to that P is fine. A to that P is fine. E to, so that doesn't work. And the next time it works is P. So what is it checking here? It's checking for this thing, and then it will remove this P, so it'll have this thing. So then it opens the P up here, and then when that works, it's going to try to close down the windows, so the window is going to be like this. Then it should, no, closes, it stops the repetition when it actually closes on the right. It closes the window, removing a consonant. So it actually keeps on removing. So, okay. So what it's doing is, like, it starts here, that works. Then it's going to remove on the left side until it moves the P, so it stops there. Then it's going to increase until it hits K equals 2, so it stops there. And then it's going to move on the left until it actually removes the P, so it stops there. And then it's going to add on the right until it gets to another P, so it stops there. And then it's going to move until, remove the left until it removes a P, so it stops there. And then increments to get another P, so it stops there. Removes from the left until it removes the P, so it stops there. And then increments P, removes P, increments P. Okay, so the issue is if it opens up the P here, and as it removes on the left side, so let's say it removes the P on the left here, it should probably stop as long as what's contained. So it definitely stops if the window doesn't have P, doesn't have this, if it removes a consonant, it has to stop. And then it should increase until there is the correct window. And it should increase until, so it increases when it has the correct window. But here, it needs to actually increase as much as it can all the way to here. Ooh, I think increment as much as it can, because technically that's all good. And then it should decrease. So, oh boy. So each time it increments on the right side, as long as the number of consonants is K, and there's at least a vowel, then that substring should work. So it technically couldn't increment here. But if it was starting like that, then it should increase here and see that this works. Increment here and see it works. And it does it all the way till there, because then the third P is going to be in there if it increments further. And then closing the window on the left. It should close the window on the left when it's removing vowels. Where the number of vowels I feel like I'm so close. Okay. Let's think about this just real closely. What if my window is not predicated on consonants, but predicated on the vowels? So I extend out the window until and keep track of the number of vowels within my window. So I extend out until I have at least one of each vowel. And then so it stops here. And then I check how many vowels, how many consonants I have in the window. There's only one, so it doesn't work. And then keep on doing it. So extend it out here, it works. And when it does work, what happens? When it does work, maybe I keep track of where the consonants are. So there's two consonants, that's here. I keep track of the first placement of the vowel. So how do I, if it's here, extend out the window along the vowels. If you keep adding more vowels, then it's possible your window still works. Wow. Let's say you start with an A. That works. And that works for having all the vowels. You add an P. That works for having two consonants. And now, do you want to close the window? When do you have to close the window? When you get an extra consonant, then you have to close the window to remove that number consonant, no? Or if your window is based on having at least one of each vowel. So this is at least one of each vowel. But there's only K, or there's only one consonant. So now if you take away having one of each vowel, then you remove the left side letters until you remove the left side letters. And if when you remove the left side letter, the number of consonants is smaller, so there's at least one of each vowel. If you remove the left side one and you could remove it though, but then you cannot remove it such that your consonant, your number of consonants is, I think you only remove it, remove left side letters when your number of consonants is actually below or above what you need. If it's already below what you need, then you shouldn't be closing your window at all. You should be opening your window as long as your window has at least one vowel and your number consonant is equal to k or smaller than k. So you open up to here and you only close the window when your vowels is less than, you have less than all the vowels and or your number consonants is less than k. Okay. So I think all this logic is kind of bad. So let's just start here. Let's say just increment the right index letter now. Actually, this should be after. This is at the end. It doesn't matter. I don't think it matters actually. If the letter is in all the vowels, so it's a vowel, then vowel set dot add this letter vowel count for this letter is incremented by 1, and then if the consonant count is equal to k and actually while the consonant count is equal to k and the vowel set the length of the vowel set is equal to 5, answer plus equals 1, and we're going to close the window, and I'll do that in a bit. Else, so this is for the consonant count plus equals 1. Actually, this should actually be applied here. Consonant count plus equals 1. I think that's it actually. So while this window is correct, you're going to increment your answer, and you're going to close the left side window. Left letter is equal to word at the left side. I need to increment left at some point, left index. And then if left letter is in all vowels, then the vowel count for the left letter is divided by 1, and if that count is now 0, then vowel set dot remove remove this left letter. And last but not least, if before we move on, if the new window is still correct, if this if consonant count is equal to k and the length of the vowel set is equal to 5, the answer should append by 1. No, I guess I just check at the very start of the next one. And I think all this stuff is bad here. The right is incremented already. Okay, let's do I need to do the post while loop here? So let's say the right reaches the end. And then I still need to, yeah, I still need to do it here if the consonant count. I think I just copied this thing one more time. So while it's still the case that even after you hit the right side being at the very last, for instance, if you try to find 0 consonants, or actually, while still true on the right side at the very end, you just need to remove stuff on the left side and add it to the answer if it works. Alright, when we increment the answer, let's go and just print out what we are seeing here. Print word at left to right. Okay, this is even worse. Excellent. So the first one it sees is here, while the consonant count is equal to k. So it should have removed it so that's here. Okay. And the next one should have been here, no? And then that should have worked. If the letters in all vowels, then do that. Else do that. Oh, whoopsie. I didn't have an else statement here. Else, if its left letter is a consonant, then consonant count should decrement by 1. Okay. So that one works. You remove the P and it no longer works, so then you extend out the right side and it hits the second P and that works. And then you I think maybe the issue is I need to extend out the window even further. I need to extend out the window even further because if it works here with PP, it could work even farther with the same left side thing. So how would I code that? So while right is less than n, okay. I think here it's while there's too many. So I don't start removing until the consonant count is greater than k. So the consonant count is greater than k, then I need to remove until it equals k. Then if the consonant count is equal to k, then I shouldn't really stop. That means the window is still valid. So anyway, so if it goes here, extends out further because it's still fine. But if I want to include this one, consonant count is adding here, then I'm adding to all the way to here. then I add the last, if I were to add one more P, it would actually be too much in terms of like I'm missing certain answers. Like technically I need to add all the way to this, but to this O, and then start closing it because like maybe this is fine, or this is fine, or this is fine, or this is fine. So I know I went too far if I have more than K consonants. I need to remove stuff. Alright, let's just see what happens if I do constant count is greater than equals K. Okay. These are all fine. So it has this one, and then doesn't close it, so it should have this one. Oh no. Consonants count is greater than equals K. While consonants greater than equals K. Let's say it's actually just greater than K. So what is going on here? So it looks for two P's, sends out here, and then it moves the left side P. So it's here. And then adds the right side P here. And then it moves the left side A so that the number of vowels is less than 5. And then it would add the right side A. Interesting, interesting. Okay. So it's ah my gosh. So it's not like all the sub windows within some windows valid. Is there a way to tell when you've opened the window how many sub windows within it? How many sub windows within it you see? I guess what you could do is you can keep track of where the A, E, I, O, and U indices are, and the smallest index of those is where the left side should be. The smallest index of those where the left side index should be. Okay. So this is not going to be a dictionary. Okay. Wonder if this is still too much. Okay, let's keep track of where the left side indices, where the indices of actual A, E, I, O, U are. I think I need to use a deck for this double-ended Q. So we're not. So maybe we still use some of this stuff, but I think the vowels may be tracked differently. So this is going to be the A deck. This is double-ended Q. The E deck, I deck, O deck, and the U deck. So each time we see a vowel, we're actually going to add it to the deck. So I guess maybe should I have an array of decks? What's the easiest way? A default dictionary of decks. Vowel decks is equal to default dictionary of decks. I think maybe this syntax would work. And then let me double check that this is actually correct syntax. Vowel decks of A dot append, let's say 4 vowel decks of A dot append 5 and vowel decks of A dot pop left. Make sure that those are the correct population. Okay, yep. So I'm going to track where for each vowel that I see, what index it is. So vowel deck for this letter, that's the vowel dex of this letter dot append whatever index this is. And let's go and just move the right to the very end here. Right incrementing. So this tracks, this is basically a list, but the list, a deck is a list where you can remove elements from either the kind of back end of the list or the front end of the list. And I'll need to remove it from the front end of the list because when I remove letters, it'll be from the front end. Okay. So if you were to add a letter, it goes there, sure. And when you have a window where let's see, when you extend out your window on the right side and the consonant count is equal to k at this point, and the length of the vowel set is equal to 5, then you should consider that the left side could be the lowest of where consonant is, the lowest of where the consonant is, or the first vowel. No, that's not right. The first vowel is not going to be the one that you care about. It's going to be the lowest among the last vowels, or the lowest among the last vowels. So the last vowel represents where the last A, I, O, or U is. And any subarrays that fuck me. Any subarrays so if you have K consonants, you have K consonants, you have K consonants. If your consonant that was prior to this, okay, I think I need a consonant. I need a consonant deck as well. I think this should just be called letter decks. So if your letter deck for a vowel, you need to keep track of that. And we'll say letter decks for the constants is K dot append, whatever the right side is. I don't know if that's strictly necessary. If your consonant count is K, so where the last U, I, E, O actually is the first or the last, or the first or last. If you just go with the last, maximum of the last, that'd be the U, and that just doesn't work. If you go with the first of the first vowel, all the way to so you know that there should be, it should work there, but you know that everything between that and side, you extend that window as much as possible. So if you have two P's, you extend it out to here. And how many subarrays of this works? Well, you can't do anything where you remove the consonant. And you can't do anything where you remove So up until where you remove the first consonant or the first vowel. But no, if you remove the first vowel, that should still work because like there could be other vowels after that that works. So like for instance, let's say you had this whole thing. You can remove up to this P, or like you can move this A because there's another A, you can move this E because there's another E, this I, this O. You cannot remove this U. So like this works to here all the way to this U. So that U would technically be the last U, last U. So the last U, the last A, the last E, the last I, the last O. There's some logic here that I'm not sure about. Consonant count equals K. Length of vowel set is equal to K. First consonant is equal to, let's say, letter dex of K at 0. Last vowel is going to be the minimum. The first one of the letter dex at A. The last one that's been added, letter dex of E. The last one that's added, letter dex of I. Letter dex of O. And letter dex of U. So all the subarrays that are either up to through the first consonant or to the last vowel. So if you're extending out here, then that means that you can close it up to, so like this, that subarray works, and then that subarray works, and that subarray works. Like you need to actually start removing the U before the subarrays don't work. So say answer left is equal to, or answer is equal to the number of subarrays from that left side to this one. So the minimum, the first one of the first consonant and the last vowel minus the left side answer should increment by that amount. So like if the answer, the left side is currently here, then it should go all the way to here. Okay. I'm not using sets and vowel sets anymore, really. Just using the deck. Is that the correct amount? So if A left is at 1 and U is at 0, 1, 2, 3, 4, 5, there is 4, 5 minus 1, 4 subarrays that have the correct left side. Okay, I think that is right. And then what you'd need is you would need to close down the left side. So for each vowel and all vowels, if letter dex of this vowel exists, so it's not empty, and the starting one on the left side, letter values of this vowel the starting element is smaller than the start left. Okay, this left is equal to minimum first consonant and last vowel. And we'll say this is the best left. If the index of where this vowel occurs is smaller than where I'm cutting off at, then letter vowels for this vowel, sorry, letter dex for this vowel. Letter dex for this vowel should be incremented, or should remove that. Letter dex for this vowel dot pop left. Okay, so you're getting rid of the smaller vowels, the first incoming vowels that are before that vowel. Okay. And that's for all the vowels. And then for actually this should be a while loop. You need to keep on doing that until it actually pops the smaller until it stops. And then for each, and you do this for the consonant as well. So consonant being K. Well, no, K is going to be K needs to, so this is breaking it so that there's you extend out the right side, and when you extend out the right side, if there's K consonants, then you add onto your answer. Do you need to actually close your window at that point? I don't know that you do. right? Because if you have K stuff here, you just need to know where the appropriate left side is, but you don't need to close it. What you do need to close, like you don't need to remove letters until you have too many consonants. When you have too many consonants, that's when you need to remove letters. If you have too many vowels, then there's no such thing. So this removal process is wrong at this point. But if you do have the right number of consonants as you extend out your window, then you need to determine where the last consonant might be, or where the last letter might be, where the appropriate left side is. And the appropriate left side should be, yeah, where the consonant is, like you can't have a subarray that has less than K consonants, so it cannot exceed where your interesting. I'm doing the same operation here, doing minimum of the first consonant as well. Well, actually minimum of the first consonant rather than the last consonant. So and out on the right side, you have a window that has K consonant and has all the vowels. And then you need to know where your first consonant is within the window, or the smallest of the last vowels within the window is. And everything up to that point should be considered fair game. This should be best left. Yeah. Here I'm not using vowel set anymore, so I should be tracking that. If the number constant is K and should track vowel set using the same deal. Using how I tracked over here. We could also track it using just using the size of the letter decks. Okay, let's just track it using the size. Oh, I kept that code here. So yeah. So that's fine as the way of adding to the left. And then if it is the case that while, so I need to close down the right side if there's too many consonants, or close down the left side if there's too many consonants. Because if I reach a point where I add like this extra P, then there's no window that works like that, so I need to close down the left side. until there's one less P. Yeah, so while the constant count is greater than K, then the left letter is equal to the word at the left, and remove it from the list. Default vowel count of this left letter just decremented by 1. Or this is not a constant necessary. If the letter is in the vowel set, the vowel count, this left letter, is decremented by 1, and the vowel set, if it is 0, then you remove it from the set. If vowel count for this left letter to 0, vowel set, move this left letter. Okay, and you keep on doing that until you reach a constant, else constant count -1. And then you also need to do something with the arrays. So the arrays being this stuff. Actually, what you can do here is you can say the dex for that vowel removes the first one that you see, because that should be within the current dex. So letter dex, this vowel, dot pop left, left side being the starting side, small side, and then here, if you're removing a consonant, then letter dex of the consonant K dot also pop left. And I don't think so. Once you pop left, and then now you're back down to K, do you need to do one last check of this? So you added too many. You added too many. Okay, so if it was previously that was like, say this, and you counted that correctly, let's say you added this, then there's no window that ends like this with too many consonants. So you actually need to remove the consonants first before you count how many correct ones you have. Okay. And I'm gonna go ahead and delete everything there. I need to increment my indices here. Yeah, so left plus equals 1. Okay, so start with my right letter. I add it to my vowel set if it's a vowel, increment the vowel count, and add it to the spots where I see that vowel. Otherwise, it's a consonant. I add to my consonant count. I see add to the spots where I see consonants. And then while I have too many consonants, I'm going to have to remove it so that there's a correct number of consonants. So when I remove the left side, if it's a vowel, then I remove it from the count. If the count is 0, I remove it from the set of vowels I see. And I remove that vowel from the deck of vowels. And then if it's a consonant, then I remove that consonant and I remove that index of the consonant from the deck. And then if it is matching that there is the right number of consonants and at least 5 vowels, then I'm going to quickly identify how many subarrays by figuring out where the last consonant is, or the first consonant within the set that I see, and where the last vowel, the first of the last vowels. So if there's like 10 A's, 6 E's, 7 I's, 8 O's, and 9 U's, then wherever the last occurring A, E, I, O, U, the first of those, anything up to that point should be fine, as long as it's before, as long as it's like doesn't exclude out the consonant. So the minimum of that and the first consonant. And then okay, I don't think I need this. I think this is old code. Out of range. First consonant. Oh, there could be no consonants, I guess. And I guess here k is equal to 0, yeah. So what would work here? So I could say here, if the constants equals k, so if k equals 0, then it doesn't really matter. I'll just say first consonant is just the last one because I don't want it to be smaller than the last vowel, so I'll say it's n. Alright, it's close. I think I need to just do one more addition of this after the loop, because at the last index it could still be some more answers. I think I tabbed this wrong. Did I tab this wrong? Yeah, I tabbed this wrong. After loop is that index. This is not. Oh my gosh. Okay, so what's going on here? So let's say, alright, this is still wrong. If you Why would this be wrong? Length of the vowel set should be 5 at that point, no? Length of the vowel set should be 5. Left is 0. First consonant, or this should be, best left should be 0. So it'd be 0 minus 0. 0 minus 0 should be plus 1. So from that left to where it is, but you don't want it to. So if you want to have two A's, then it should be 1 0 1. It was like A E I O U. Then this A is going to be the first one, so 0. So that array. So if it's like K equals 0, and you had A E I O U, then you extend out here, and you should have 3. And the last one is this one, which is 2. The first one here is 0. 2 minus 0 plus 1. Okay, so that kind of fix it for those two. Let me do a test case here. So A E I O U. So is my handling of that case fine? No. So it should extend out to here, and at that point it should add 3. And then the left side should be here. Well, it adds 3. Does this thing ever remove the left side if the consonant count is never going to exceed? Probably not, so it never hits this code. It always hits this code. So first time it hits that, then adds 3, and then the next time adds 3, and the next time is it hits this, and it should add another 3. And then the next time it hits it, it should add another 3. Okay, let's go ahead and just add here. Print print adding answer starting this will be the word from the left side to through the right side plus 1 at this point, and through word from the best left to the right side plus 1. I'll insert that here as well. Oh shoot, got it wrong. Missing a comma. Missing a parentheses. Okay, so okay, and then let me go ahead and insert how many answers it. Oh my lord, this should be +1. This is probably going to be too much though. Yeah, it's too much. Too many answers. I wonder if this should have been just +0 here and +1 there. No, it still doesn't work. But everything else worked, huh? Okay. So, I mean, it's correct here, and this is also correct. Do I even need this last part then? Maybe it's just the fact that I don't need this. Oh my lord. Okay, that was it. All right. Okay. Let me think about how this thing should be optimized. I think maybe using a double-ended queue plus a list plus a set is maybe overkill here. Yeah, so I'm using 4 more megabytes here. Do I need to keep track of my consonants? I kind of do, because it's the quickest way to me identifying where my first consonant might be. So the decks are probably fine. I think the default dictionary could be just using the length of my deck. So since I'm already appending it to the deck here, I'm going to remove the counter, and I'll just say if the count. So if I pop left here, and after I pop left, if the length of that deck is equal to 0, then vowel set, remove this vowel. Okay. I think that's the only time I make reference to that. I could just remove the vowel set and say here if the length of the letter decks for A, E, I, O, U are there, then I know that there's at least one of each vowel. That could remove the vowels at all, or the set at all. I think I can probably get away with that. Yeah. So if I think the shorter way, instead of looking at the length, if I just call if and letter decks of A and letter decks of E So when you do that, you just check the length being non-zero. Letter dex. Actually, let me just first check that the other way just works fine. Vowel set, not remove. If the vowel count for this thing is equal to 0. That's supposed to be there. No, I think. Okay, let's double check if that works. Okay, let's see how that compares. So I could still remove a set here from the stuff I store. Okay, that didn't really change anything. I wonder if the dex is really what's really keeping this from getting smaller memory. Probably a set probably isn't that much of a deal. But the set check and removal still takes some time. Okay, let's go with it. If the length of the letter dex at A equals 0, and the length of the letter dex of E is equal to 0, length of letter dex of I is equal to letter dex of O shucks, length of letter dex of O equals 0, and the length of letter dex, wow, U equal to 0. Okay, see if that works out fine. Actually shouldn't be equal to 0, it should be just something. So it's not 0. Okay, so let's go ahead and remove the set now. No more set. No more set. No more removal set. Alright, I removed all the instances of the set. Alright, let's see how that runs. Wow, it runs even slower actually. How is it running slower? What? So the set actually helped it? Oh my lord. Guess you only compare the length each time. Huh. Interesting. I mean, yeah, I guess it is not terrible in terms of speed of checking things. I didn't know that it'd be that much better though. But it does seem that way. Okay. Is there another way to do it then? To speed this up? I mean, I am pretty efficient in terms of whenever I see the vowel, I remove the vowel. Decks aren't that bad. My memory usage is kind of really high. All the vowels. You add onto the right side each consonant. And then you move on the left side. Oh, you know what? Maybe instead of doing the min of this thing, is there a way of not doing the min here, but just automatically increasing? So the last time you see an A, the last time you see an O, I or U, so if you see a new A, can you increment? Could you change some other variable? So if you see a new A, then that new A would pop onto the letter deck for A, and then wouldn't necessarily, it would make possibly some other letter be the first appearing of the last. I don't think I don't think that works. So if you see another A, then the last A, if the minimum, then you need to recalculate the minimum. If this is a low, no. This is still pretty fast. Okay, well, so just as a summary, what's happening here is so what ended up happening where was track. Okay, you extend right. Extend window by right letter track placement of vowels and consonants in index if current window has k consonants and actually there's one step between this thing, but if the current window has k consonants and at least one of each vowel, determine earliest, or actually it'd be kind of the latest left index to window. So the latest left index to the window would be one where it still has k consonants within it, and um, that still has k consonants and at least one vowel. Latest left index is equal to the minimum of the first consonant in window and first of last, min of last vowels. So so you see where your last A, I, E, and O, U are. Like the first one of those is the index where you can still guarantee that there's at least one A, E, I, O, U, but it needs to also be, you also need to have the first consonant within that. So whatever's smaller of those two is going to be the last best window, or last valid window, and the answer plus equals like the number of valid windows between where left is in the range of whatever the left index is currently, and whatever the left the best left window by that calculation is. And then yeah. But technically, once you extend the window by the right side here, this could actually give you too many, if too many consonants, actually, where basically it's more than k. Then close window on left. Close window. So this means repeat, to delete, take left letter away from track of consonants. And vowels. Alright, so this is adding the letter. Adding letter is just adding to the set of vowels and adding to where the decks are tracking the indices of those letters, of those vowels and consonants. If it's a consonant, then you're adding one to the number of consonants, adding that index to the number to the double-ended queue of consonants. And then while your kind of windows has too many consonants, then you need to just remove stuff on the right side. This is your left letter. Remove that left letter from their deck and remove it from the set if the deck has 0 elements. Otherwise, remove it from the number of consonants and remove that index from the indices in the deck of consonants. And then increment your left side. And then once you've removed everything and you have a valid number of consonants, k consonants, and also at least one of each vowel, then you determine like what your best left is, or your latest left is. Again, that's going to be the minimum between where the last A, E, I, O, U is and where the first consonant is within that time frame, within that window, because you can't remove that consonant. Alright, time complexity is going to be, this should be O of n. It's linear with the number of elements, because you are just increasing the right each time. You're doing some amount of work, but none of this works is more than just a kind of fixed amount. And then space complexity, well, there's going to be, this is also O of n. The decks grow in size up to, like, the number of elements tracked in the decks is basically equal to the number of indices there, which is n. Decks are approximately gonna be the size of lists. Set here can have up to 5 elements. So yeah. Oh my god, that was brutal.